We tend to view evolution as a staircase, a steady climb from simple cells to complex, intelligent life. We naturally assume the end goal of biology is to become stronger, smarter, and ultimately to dominate the ecosystem. Look at the dinosaurs. For over 160 million years, they were the undisputed rulers of this planet. They evolved into highly specialized apex predators and massive herbivores, filling almost every ecological niche available. But mass extinctions do not care about dominance. They are a problem of velocity. Under normal conditions, evolution unfolds slowly over millions of years. But during a planetary reset, the environment changes far faster than biology can respond. The KPG asteroid impact is the most famous example. A rock 6 miles wide struck the Earth, blocking the sun and collapsing the global food chain. An evolutionary reign that lasted 160 million years ended in a matter of geological minutes. In that sudden darkness, the exact traits that made dinosaurs dominant, their immense size, their high caloric needs, and their specialized bodies, became fatal liabilities. The top of the food chain was the most vulnerable place to be. To see how absolute this vulnerability can be, we have to look deeper into the fossil record. Around 252 million years ago, Earth experienced the Permian-Triassic extinction event. It remains the deadliest biological catastrophe known to science. The collapse triggered when immense, sustained volcanic eruptions in what is now Siberia released massive quantities of greenhouse gases, severely heating the planet and turning the oceans acidic. These individual disasters initiated a chain reaction. The warming oceans lost their oxygen and released toxic gases back into the air. Earth's biological and atmospheric systems actively accelerated their own destruction. The resulting vacuum was near total. Entire forest ecosystems collapsed. An estimated 90% of all marine species were completely eradicated, leaving behind nothing but dense, chaotic layers of fossilized bones. When the planet resets its own ecosystem so violently, and the strongest, most specialized animals are systematically erased, it poses an obvious question. What specific biological traits actually allow anything to survive? The answer looks a lot like the horseshoe crab. This lineage existed long before the first dinosaur. They lived through the Permian catastrophe, the asteroid impact, and 3 other major planetary resets. We usually assume evolution constantly pushes life toward innovation, but the fossil record of the horseshoe crab shows remarkably little anatomical change over hundreds of millions of years. Nature does not always reward biological tinkering. This diagram illustrates the specific survival parameters of an adaptable generalist. Extinction survivors tend to have small bodies, flexible diets, and the capacity to tolerate wide swings in temperature and atmospheric chemistry, a stark contrast to apex predators requiring specific, inflexible inputs. In evolutionary biology, primitive often indicates a hyper-robust body plan, one thoroughly optimized for absorbing extreme environmental shock, making further structural changes completely unnecessary. We see this exact pattern in other deep-sea survivors. Nautilus species still carry shell structures that predate the Mesozoic era, and the coelacanth, a fish once thought to have died out 66 million years ago, still swims with the same ancient anatomy today. The true inheritors of the Earth have never been the dominant rulers. They are the quiet, unassuming generalists capable of riding out the apocalypse. To find the absolute outer limits of this survival logic, you have to look at the microscopic scale. These are tardigrades. In laboratory settings, scientists have actually exposed them to freezing temperatures near absolute zero, levels of radiation thousands of times beyond what humans can endure, and the vacuum of outer space. Their biology utilizes a specialized mechanism called cryptobiosis. Under extreme stress, they rapidly expel water, fold inward, and nearly stop their metabolism entirely, turning into tiny, dormant husks. An organism does not evolve the ability to survive outer space because it lives on a peaceful, stable world. It develops these extreme tolerances because its environment is periodically volatile. Tardigrades have survived for 500 million years because their biology treats catastrophic planetary instability not as a rare anomaly, but as a predictable baseline condition. When we apply this analytical lens to ourselves, the picture becomes rather unsettling. Over the last 10,000 years, modern human civilization has structured itself into a highly optimized apex ecosystem. Our massive population density and global agricultural output rely entirely on the absolute predictability of seasonal weather and stable global climate patterns. We have built highly specialized global supply chains, where goods are manufactured and shipped with extreme precision. That absolute efficiency leaves practically no margin for systemic failure. And our densest cities rely on uninterrupted, highly optimized energy grids and technological infrastructure to function minute by minute. In our pursuit of immense power and total efficiency, we have adopted the exact architectural vulnerabilities that mass extinctions reliably target and erase. We naturally assume that our intelligence and technological continuity will act as guaranteed failsafes during a true planetary scale disruption. But the deep history of Earth suggests otherwise. Natural selection has no moral direction. It has no preferred species, and it does not inherently protect complex intelligence. Human civilization occupies a microscopic fraction of Earth's timeline. The ancient species resting at the bottom of the ocean witnessed the beginning of our world, and they may well watch it end. Because the ultimate evolutionary victors are not the organisms that conquer the planet. They are the ones that simply learn to endure its inevitable endings.